Welcome to Smart Notebook Math Tools. In this session, we'll look at how to use the lines tools and the shapes tools to create arcs, perfect circles, perfect squares, and a variety of triangles. If I select the lines tool icon from the toolbar, it will display selections of lines of different styles. Added newly to this list is a curved line, which allows me to create an arc, and a directed curved line, which allows me to create an arc with an arrow. Let's see how these function in an example. Expand the following algebraic expression. I can now select for the lines tool and a directed curved line to show the multiplication between 2x and 3x, and then between 2x and minus 5, between 1 and 3x, and then between 1 and negative 5, as I review the distributive property. When I look at the Shapes tool icon and select for that in the toolbar, I see now I have a variety of shapes to quickly draw any shape that I would like. So selecting for the circle, a perfect square, an isosceles triangle, a scalene triangle, and my special triangles. I can use these in an example to show how quickly we can create questions for the students to solve. Here, construct a rectangle and a square to study its properties. In the previous version of Notebook, we only had the rectangle tool to do this. So we could create rectangles quickly, but then we had to struggle to create a perfect square. This is no longer the case, as we have a square tool to quickly create a square. Looking at an example for triangles, to determine the height of the tree, I can select for a special triangle from my Shapes tools. Using the triangle with angles 30, 60, and 90, I can very quickly create a special triangle from the tree to the girl's line of sight, and then giving the students two of the measurements in a triangle, for example, the angle of elevation or the distance from the girl to the tree, they can solve for the triangle and get the height of the triangle and then determine the height of the tree. In the next session, we can see what has been added to our regular polygons.